Welcome back to Hacking Math. Today we're looking at a classic calculus problem, the good old cone problem. This cone is made by cutting a sector of angle phi out of a circle with radius 12 inches and taping together the resulting edges. Maximize the volume of such a cone. It's a maximization problem. So you're cutting out this part of the circle. We'll call it X since we're not in Greece. That means that that arc length is going to be a certain ratio of the circumference. So it's going to be 360 minus that angle divided by 360, that fraction of the circle, times 2 pi r. Well, we know that r is 12, so it's going to be what, 24 pi. So that's the arc length, which is going to become the circumference of the base of that cone. So if we know the circumference, we can find the radius of the cone. If you know the circumference, you want to know the radius, you just divide the circumference by 2 pi. We should start making Python functions out of these. Arc length, and then you do that to the arc length to get the radius, and then you'll do that to the radius to get the height, and then you do this to the height and the radius to get the volume. All right, let's fire up Python. So here's our Python program. From the math module, we're going to need pi and the square root. Now remember, the arc length was a function of x. So I'm going to define a function arc length, take in x, and return (360) minus x divided by 360 times 24 pi. That's going to be the circumference of the circle, and we said the radius of the cone was going to be the arc length divided by 2 pi. Then the height of the cone was going to be based on the radius. Let's see. Let's put the cone right way up. We know now that this is 12, this is the radius, and this is the height, right? So the height is going to be, well, the height squared is going to be 12 squared minus r squared. So the height is going to be the square root of 144 minus rx squared. We can write that function out. And then we've just got the volume, and the volume is going to be 1/3 pi r squared h. So pi over 3 times rx squared times h of x. Of course, that's arc length. Arc length. Does art have a length? All right. Let's define the height of x. Return square root of 144 minus and the volume pi over 3 times okay. Now all we have to do is to print out everything from 0 to 2 pi for x. I'm sorry, we're in degrees, so let's just keep it as from 0 to 360 let's make x equal to 0. Then while x is less than or equal to 360, print out x, the angle, and the volume with that x. After that, make x go up by 1 degree. All right. Should we print that? R is not defined. That's right, we called it radius. Let's just say R. Cool. Well, so when you take out 360, the volume is 0. That's a good sign. So it's going down, going down. Let's see. Looks like 500, 600 cubic units. Then it's going down again. So let's see. Where is it the highest here? 696.49, around 66 degrees. So that's our answer. That was quick. Let's see. We'll just make sure that, let's see, let's use the derivatives to find out, is that really where the derivative goes from positive, meaning the volume is increasing, to being negative. So around 66 degrees. Let's take a look at our program again. Let's make x 64 degrees. And while x is less than 67 degrees, can make it go up by hundredths or something like that. And let's see, we're going to print x, and then the volume, it goes up by a tiny little bit, like delta x. I'll just say dx. And that's going to be 1 divided by 1,000,000. So we want to print out the volume of x plus dx minus the volume at x, and then divide both of those by dx. It's the slope. So that's the rise and the run is dx. Let's run that and see what happens. All right, really negative. That's definitely not right. Let's see. Here's a good lesson about the order of operations. We actually want Vx minus, sorry, this x plus dx minus Vx, that whole thing, we want that to be divided by dx. Then close that. Yeah. Let's try that. Much better. See, it's going down. And now it's positive. Where was it? Pretty much at 0 at 66.06 degrees. Anyway, this is a classic calculus problem, and the solution showed up in the book that I contributed to the calculus section, called The Statistics in Calculus with Python Workshop by the good folks at Pact Publishers. Anyway, that's it for this video. Please like and subscribe, and we'll see you in the next one. Bye.